without further ado, I'm going to introduce tonight's speaker. So anybody who's been a member of HAS for any amount of time is familiar with Brian, and Brian is one of our most prolific users of the observatory, does a lot of scientific observation there. To introduce Brian, Brian's interest in astronomy dates back to the 1970s, but really picked up speed early in the 80s when he received his first real telescope, a 2.4-inch refractor, same type of telescope I got for my first telescope. As a student worker while attending North Arizona University, Brian assisted Gene and Carolyn Shoemaker with the Palomar Asteroid and Comet Survey and was working with them when Comet Shoemaker Levy 9 was discovered in March 1993, so really exciting. Since 2001, Brian has been the physics laboratory manager at Prairie View A&M University, where he's been recently working to open the new Prairie View Observatory complex and make it available for faculty and student research and instruction. The observatory includes an existing solar telescope and 2 new domes housing a Meade 16-inch and a plain wave 24-inch telescope. Kind of a shameless plug here. Brian is also the author of 2 books, Lunar Meteoroid Impacts and How to Observe Them, and Faint Objects and How to Observe Them. So I've read one of those books, Brian, and need to get the other one. In addition, he serves as editor-in-chief for Encyclopedia of Lunar Science. And Brian, I think I saw that's going to be released in 2022.
That's correct, 2021,
okay.
2022.
Excellent, okay. All 3 books are published by Springer, I believe, as well, correct?
Yeah, the only thing is the Encyclopedia of Lunar Science is a bit expensive. It's about $900, so it's geared more towards professional institutions. But if you have that kind of money and you would like to spend for a resource like that, you're welcome to do so.
Excellent. I was wondering if that was a typo when I was looking that up. I saw something like $800 on the Springer website, so that's really good. So one thing before I hand it over to Brian is if you have questions for Brian, please include those in the chat. So down at the bottom, you'll see a button for chat. Just type in your questions there, and when Brian gets to the end of his presentation, if you don't mind, Brian, maybe you can take time to answer a few of those questions.
Okay.
Perfect. Okay, I'm going to go ahead and stop my share here. And it's all yours. Thank you, Brian.
Okay, here we go. So I have been doing this online thing with the class I taught in the spring when we went to online after spring break. So it's kind of like what I've been doing all along. It's just a matter of getting it to work because sometimes it's a little bit slow to get started. But anyway, the presentation that I'm going to give this evening is kind of a description of a journey, kind of like a cosmic journey. It's been basically almost 22 years in the making, and I'll explain why in just a minute. But as Joe had said, I had been interested in astronomy since for about 45 years now, and I've started observing in one form or another in the early 80s. And I'm primarily a visual astronomer, and so I've enjoyed a lot of visual sights along the way, but I do also dabble in a little bit of basic astro imaging, which this observatory has given me the opportunity to do before we had to kind of shut down because of the lockdowns that were taking place because of the pandemic. But I'll go ahead and get started. This month, as a matter of fact, a week from tomorrow, marks exactly 22 years since I've arrived in Houston. And I came by way of Arizona, where I earned my undergraduate degree in physics and astronomy, and San Diego, where I earned my master's degree in astronomy. And then an individual by the name of Bob Odell, the father of the Hubble Space Telescope, wanted to hire me on. And so that is how I was relocated to Houston 22 years ago to work with him. Apparently, he was expecting a PhD type quality work from a fresh master's graduate. So that ended up falling through after only about 3.5 months. Houston was a very new place to me. I had never been to Houston, no family, no friends, and so forth. So it was, you know, a stranger in a strange land, so to speak. But fortunately, there was something developing at Prairie View A&M University. As a matter of fact, in October of '98, I first set foot on the university to look at their new solar observatory. The building had been constructed earlier that year, and they had ordered a telescope, a 35-centimeter vacuum solar telescope from Nanjing, China. And so that was craned into the observatory before they put the top of the dome on. Before I got there, I didn't get to see that. So that was put in place, and so I had the opportunity to help out with getting that set up from November of 1999 through September of 2001. So my official start with Prairie View A&M was May 1st, 1999. I actually had worked through Rice University prior to that to not only work with the outreach program at Rice University, but also to work with the Solar Observatory program at Prairie View. And so the principal investigator of that project, Dr. Tiansen Huang, already had an idea of expanding from the dome. And so I actually designed a building, a small building with a second dome in November of '98, and I couldn't find the plan, otherwise I would show that in my presentation, but it included classrooms, a second dome, a machine shop, and so forth. So that actually started the journey of the observatory addition that I'll talk more about in just a minute. So, but politics, of course, is a universal phenomenon here on planet Earth. Because of that, the Solar Observatory divorced from the Physics Department in February 2001 and became its own entity. Since October 2001, because of budget problems, I was let go from the Solar Observatory research group, but I was picked up as laboratory manager at the Physics Department with a 50% raise. So even though I was losing the observatory, I was gaining a little bit more income to buy the house that was being built at the time. So I had been involved in the routine solar observation program from the spring of 1999 through September of 2001. And the program actually continued through 2015, and I'll show some examples of some recent images that we have, that more recent towards 2015, that we had obtained from the Solar Observatory. And you can see this is the dome itself pointing towards the sun. This is actually from Dr. Saganti's webpage. He's now the current principal investigator of the Solar Observatory. Back then, when we were making observations with the original vacuum solar telescope, it's called vacuum because it has you'll see a picture of it, it has a cylindrical unit that is evacuated. We suck as much air out of that as possible so as to reduce any turbulence within the tube. The sunlight comes through the corrector plate, and most of it's rejected out of the side of the instrument, and a little bit of it makes it through, passes through the hydrogen alpha filter, and also through a 5 arc minute by 7 arc minute rectangular aperture that we use to look at pre-selected images, pre-selected regions of the sun, again in hydrogen alpha light. So the primary purpose of the observing program back then was to target active regions and also look for solar flares. Active regions are basically sunspot groups or centers of activity on the sun. And when I was working with the Solar Observatory initially, 1999 to 2001, the sun was at near maximum activity. So I was able to observe quite a number of beautiful solar flares. And so I was informally dubbed the senior observer by Dr. Huang. And I was there to find and document solar flare activity. And we've published a number of papers as a result of our observations. We also observed the November 15th, 1999 Mercury Transit. It was a grazing transit, and we got observations of that from the observatory. So these are some examples of some images that we've gotten. Now the optics aren't perfect. The trained imaging eye can see that right away, that there is some fuzz and some vignetting, but you can see nicely the solar flare. This is active region 12192. This was actually taken in 2014, October. This is the largest sunspot group / active region that occurred on the sun during the last solar cycle. And what we're seeing there is a X1 / 2b flare. What that means is that the X-ray classes, it's considered a major flare, and optically speaking, it's a bright flare. You can think of 2b as being too bright. It's actually on a scale of 1 to 4 in terms of the brightness. That's about 7 minutes after peak. The second circle shows an X3 flare about 11 minutes before peak, coming from the same sunspot group. In addition to flares, we've also observed filaments. We could see a nice quiescent filament here, and then some prominences over here on the edge of the sun. So we also observed transits of Mercury across the face of the sun. This is the Mercury transit from November of 1999. Rather interesting experience that led to a paper that I published as sole author in the Solar Physics Journal. I'm sure many of you have heard about the black drop phenomena that has been observed in planetary transits. Well, I also have included description of what I call a gray drop phenomenon. You might actually see a little bit of that here, where there's a little bit of gray that joins the disk of the planet to the sun. And it must have been a really good paper, because one of the referees, usually in the professional circle, when you submit a paper to a refereed journal, the referees remain anonymous, so you don't know the identity of the person who's judging your paper to be published. Well, this one referee chose to reveal himself, and so he really appreciated the paper. I haven't had much chance to do much more work on this transit phenomena, and I think he might have taken my ideas and ran with it for himself. But this center image is an image of the partial eclipse of the sun that happened on October 23rd, 2014, with the nice large sunspot near the center. And then at the right is the more recent Mercury transit, November 11th, 2019. We actually had exactly 30 seconds of view of the sun. We were going to observe this from the new observatory, but we had lots of clouds that day, but the sun did come out for about 30 seconds, and I was able to aim a 4.5-inch telescope to the sun and capture this with my cell phone. So the original principal investigator of the Solar Observatory retired at the end of 2016. He was kind of motivated to do so. So as a result, the Department of Physics was asked to take over the Solar Observatory and all of the entities that go along with it. There's a plasma fusion lab. There's a what they call an electric spray, and then of course the Solar Observatory itself, which I'm most familiar with. So we took that over. Back in 2012, an opportunity came along from the Department of Education, Title III, to apply to submit a proposal for Title III money to fund an activity on campus. And so we decided to beef up our astronomy presence through this Title III grant. And so through the money, we're able to get a lot of wonderful equipment, new telescopes, and the like. And we also, towards the end of the funding period, we were able to fund the refurbishing of the Prairie View Solar Observatory building, not the telescope, but the building, to bring it up to code, to make it more in line of the safety requirements of today versus what the safety requirements were back in 1999-2000. So that renovation took place in the fall of 2017. In the meantime, we were going through designs, possible designs, configurations for an additional 2 to 3 domes that would be placed around the existing observatory. And so we've probably gone through maybe about 10 or 12 different design concepts from the time that we started thinking about the observatory addition to when we actually began construction in the summer of 2018. My original vision was simply an Astro Haven clamshell dome on the ground, housing a larger telescope next to the existing solar observatory, but that developed a little bit more since then. So the solar observatory renovation took place during the fall of 2017, and then the solar observatory addition, as it was called, started in the summer of 18. And so we're going to look at some construction images as this observatory came together. So again, we can think of this as being kind of a thing that was almost 22 years in the making, starting from that initial idea back in November of 1998, and then that was tabled for about a decade and a half, and then we came back to it in the mid part of the last decade. So this is what the facility looked like before we started building the addition, just the one dome by itself, housing the telescope up at this level, and then the bottom level is more like the control room. And then ground was broken back in September of 2018. We can see the first thing that went in are the piers. This is the where the pier was going to go down into the ground to a depth of about 16 feet. The forms were taking shape here, and the concrete eventually was poured. The structures to to shape the concrete were erected up to a height of 24 feet above the surrounding ground. So the point was to bring the telescopes above the existing dome. And so those two domes set higher than the existing solar observatory dome. So we have the piers here completed. And then the foundation was laid for the building. So what had happened was we had agreed upon this design, which included pretty much everything that we wanted in an additional observatory, but it was done at a relative on a budget. Since we only had a couple of million at the most to spend, we opted for what's called the design and build process, where we make the design, and as we're tweaking the design and finalizing aspects of the design, we would actually start building. And the reason why we did that was because by the time we actually got to the groundbreaking, the time was running out to use up the money. We had to spend all the money by the end of 2018, or else it would go back to Washington, D.C. And we know that Washington, D.C. already has enough of our money. So, but at any rate, the building itself comes to form. We see the building here before they put the exterior brickwork on, and then we see the brickwork has been placed, and actually we're seeing the base of where the west dome is going to sit. And then the interior of the room, we see it's designed to be more or less utilitarian. It's not the prettiest design, but it's something that is functional and something that is useful. What we're looking here, we're standing in the middle of what's called the visitor center, and this is looking at the east dome side. We see the pier going up through the 2 floors and then up to the dome level, and then we're looking at the west dome side on this side. And then we go up to the control room on the west side. This is before they installed the stairs, so we had to go up a ladder to get to the level as they were doing the construction. And then here's the way that we get up to the domes themselves. This is what's called a ship's ladder, where you alternate feet going up, going up the stairs. It took some getting used to, but now I'm pretty much able to go up and down pretty effortlessly. Then the drywall was put in place. This is a view from the east mezzanine level, otherwise known as the control room of the east dome, looking across the catwalk to go to the west dome. And then this is another view from the east control room. So, and then the domes arrived in December, mid-December of 2018. This is the Astro Haven clamshell dome that came in pieces, and then the Ash dome also came in pieces. And so we see pieces of our domes. They both arrived at about the same time. The Ash dome, we see the pieces after they've been unpackaged. They used a sort of a lifting mechanism to lift it up to the second to the dome level, and so the pieces here have been lifted to the dome level, and the workmen are getting ready to put the thing together. So, and this is the domes that are being constructed. The assembly is in progress. The Astro Haven dome was assembled on the ground, and the Ash dome was assembled in place. And so the pieces were put in place, and the dome was built up right there in sight. And then this is what the Ash dome looked like. You can tell that this is a brand new Ash dome, and this is a 20-year-old Ash dome by the coloring. It's more of a dingy gray, and you can see if you look carefully, here's the wax and gibbous moon, and the Astro Haven dome right here, which will go on the east side of the building. The actual lifting and placement of this one happened while I was with family in Ohio during the holiday break, so I wasn't able to see that as it happened. Fast forward about 5 months, and we get the telescopes themselves and the supporting structure that goes with the telescopes. We had a ring-shaped plate that went into the east dome, and it was designed to accommodate not only our 16-inch Meade, but at a later point we can remove the 16-inch Meade and install a 1-meter plane wave telescope. So it is the base plate is already in place for the 1-meter plane wave in the east dome, and the clamshell dome is big enough to accommodate a 1-meter or even a 2-meter. Plane wave is now producing 2-meter telescopes. In the west dome, this plate, which is about 600 pounds, was crane lifted up through the opening of the dome and then down onto the top of the pier where it was bolted in place. The plane wave 24-inch was also crane lifted crane lifted and move through the dome opening. This is an extra wide opening so that if we want to install a 1-meter telescope in that particular observatory, we can do so. They can easily move the telescope through the dome opening. And here we have the dome opening, the telescope being put in place. We kind of gave these guys nickname. This is Dome Dave from the Ash Dome Observatory Company, and this is Bisque Bill, who worked with Bisque, the company Bisque that produces the ME2 mounts that we used for our telescopes. And this, what we have the Planewave 24-inch mounted on in this case is a Taurus 700 fork mount, and we decided to go with that one to avoid the meridian flip when the telescope is tracking an object across the sky and it passes the meridian. Then it has to flip in order to continue tracking the object. So here we see, this kind of reminded me of the Hubble Space Telescope flying through the air, flying through space, as this was hoisted and lifted into the observatory. So we also have some additional equipment that's pretty unique. Actually, both of these equipments together, actually one of these cost more than my house. But what we have here, this is what we call the eyeball. This is what's called the Helios system. It's a system that produces a uniform surface that we can take our telescopes and cameras, set against it, and we can do an initial calibration. What I've done before we put the Planewave in place was I collected a large number of flat fields of varying exposure times and varying light levels to characterize the response of the camera and also the telescope system. Now, of course, that's going to change as we use the telescope and dust gets on the chip of the camera. We have to continue taking flat fields, but this is sort of a first step. What we want to do at some point, once I get a chance to learn how to do this, is to find a way to use this system in order to flux calibrate astronomical sources. So that's a work that's still kind of on the drawing board. And then this system at the bottom, this is what's called the QES 1000 system, and it's a slightly different variation of this large system. My graduate student that's been working with this is more familiar with how this works than I am. But this essentially, we use that to analyze the performance of cameras and CCD and CMOS chips. So this is the old solar observatory, formerly known as the Prairie View Solar Observatory. Now I refer to this as simply the Solar Observatory or the South Dome. And so as we go up to the second level, we see the it's pretty much looks like a workroom with a bunch of storage, a little bit of storage, and the telescope itself. Again, this is the vintage Nanjing Chinese telescope that we have still in place. We still need to address some of the problems with the optics and the vacuum system, but this top part, this is the part that gets evacuated. There's a vacuum pump that is down at the bottom on the floor, and that is operated to evacuate the air out of this tube to reduce the turbulence within the tube and to control the seeing. And then this box here is just an empty box with collimating lenses on either side that make the incoming light parallel, so we can pass it through an H-alpha filter. I also have a beam splitter cube that will enable us to split the beam into two beams so that we can pass one beam through a H-alpha and the other beam through calcium K, and these are two different types of filters. If you're not familiar, the hydrogen alpha filter isolates a particular red part of the sun's spectrum that is coincident with the hydrogen emission line, and then calcium K isolates a violet line near the ultraviolet boundary. And in both cases, we can look at different features. We can observe different features of the sun that we can't see with just visual. This big rectangular box that we see, this actually is what's called a full disk solar telescope. I don't think they've ever gotten this to work, to my knowledge, but it was supposed to have been set up so that it can tune, it can isolate light from all across the visible spectrum and tune to whatever emission line we want to study on the sun. And also at one point, this observatory had the capability of imaging the magnetic fields of the sun. And this is the ground level of the solar observatory building. We need to still develop this a little bit. We have lots of internet connections that we can use to control the telescope from the control room, but we need to set this up. That's going to be one of the next projects. Right now, it's more or less a storage room. And then at the dome level, we have the plane wave 24-inch. We are having some issues with this telescope. So this journey that I've described so far is not over by any stretch of the imagination. We still have a ways to go. This is a wonderful telescope. It turned out to be a little bit more complicated than what we were expecting. And in fact, even the person that one of the salesmen of the telescope that has been working with us, he says that the 1 meter is a simpler instrument to operate than this 24-inch. So we're working through those details. We have the camera, which we do have the, you have to have just the right number of pieces in order to have the camera at the right position in order to achieve focus. And also because we used a fork mount, we had to add about 65 pounds of weights in order to balance the telescope. And there's still a little issues with the balancing. And we're running the whole setup with the Sky X. And so, as some of you know, that controls the telescope, the dome, the camera, and so forth. I've been using that in the East Dome, and of course, we use that at the dark side with the 14-inch. And so there's some issues with the Sky talking to the dome software and getting the dome to sync up with the telescope. So, so far we haven't gotten first light with this one, but we do plan to work with this again over the summer and hopefully start imaging either later in the summer or sometime in the fall. On the West Dome, we have the control room, which right now it's mostly storage, but we will have a computer set up. We have one right here. This is a Dell Aurora computer. It's a high power workstation that we can use to reduce and process large numbers of images. And this little white telescope here, this is actually important because that's the one that came with me to Casper, Wyoming in 2017 to watch the total solar eclipse. And so I was able to get it on the plane as carry-on luggage. I took the tube off, but then the base kind of got broken. You can see if you look carefully, there's a crack down near the bottom right here where the base got cracked because of the small space that's allotted within the typical aircraft. So, but it still works. It's still a workable telescope. My colleague who was doing an observing program on campus while I was in Wyoming accidentally let the undiluted sun through and melted part of an eyepiece. But anyway, that's another story for another time. In the East Dome, this is the Meade 16-inch set up on a tall pier with a ME2 mount and an S-Big 1603 camera. This is the setup that I've been using for nighttime deep sky imaging and also for daytime solar imaging. Now, I'm primarily a visual type of observer, but I had done my share of imaging back in the early days with observing the sun. I've done a little bit of video astronomy with lunar meteoroid impacts and asteroid and lunar occultations, and more recently with the East Dome becoming operational, I was able to do some nighttime observing, and I've posted a couple of images here and there to the HAS website. So we have, it's a relatively simple setup, the Meade 16-inch, the camera, an ME2 mount being controlled by a computer that's just off of the side, and that runs the Sky X, which of course controls the camera, the telescope, and so forth. And so for solar observing, we do have some additional components that we add. One of them involves a over the aperture energy rejection filter, which is it looks like a big piece of aluminum with a small circular opening, and there's a yellow glass in that opening. So we put that over the top and we line up the opening with the tilt of the hydrogen alpha filter, which then goes on this end just before the camera. We have the hydrogen alpha filter. Then we have a neutral density filter that blocks 90% of the light, lets 10% of it through to reduce the intensity so that we can image. And then, of course, the S-Big camera. So we've been using that setup for the observation of the sun. Again, with the current vacuum solar telescope, we're now having problems with the vacuum pump. It's not working properly, so we cannot evacuate the tube. So we have to work with that. And then once we get that done, we have to look at the optics. And so we still have some work to do on the original solar observatory, but for now, the Meade 16 is our solar observatory as well as our nighttime observatory. And the control room is, this is like my second office here. When they were doing some work in my building over the last holiday period, this is where I set up office with the computer. And then this is like a secondary desk where I keep, this box is actually the temporary storage of the energy rejection filter. It has padding inside so we can keep it padded and safe right there. And so, like I said, this is a pretty simple setup, pretty basic, functional. It has just enough that we can get things done, and it's not really too expensive. And then finally, the visitor center, if you go across the catwalk, you'll look down and you'll see these large screens. We see two of them here, and then there's a third one here, hidden behind my picture. From my view, I can see myself here, and then the screen's actually behind me. But you'll notice all these telescopes. These are Meade 10-inch telescopes, except for this one. This is a Takahashi 5-inch refractor. We also have a Meade 14-inch and another Meade 16-inch, which is actually down here in the box. And so the plan for these telescopes is to put them on mounts. I found a person in Southeast Houston that makes these sturdy mounts that have wheels where you can mount the telescope on these mounts and then wheel the setup outside, lock down the wheels. The telescope would be sturdy and stable, and then we can polar align it and use it for outside, outdoor, informal viewing. So we have the telescopes. We have 40 chairs that we can pull out and set up. We already hosted a group of elementary school girls last summer for the Summer Day of Science. And so I gave a presentation, and we gave a sort of a virtual tour through the TV screens. We're not allowed to bring large numbers of people into the work areas or the control rooms, but we can show pictures of those areas to visitors. So this screen will be set up to take a video feed from the plane wave. The idea is to get a color deep sky observing video camera and hook it up so that it streams video to this screen, and that visitors can look at that. So we have large numbers of people that can see the same image at the same time. And then on the other side, this screen will be connected to the Meade telescope, and we can have that looking at the moon or a planet or another object. And so the people can see everything that we look at with these telescopes. This room not only has the regular white light by day, but also if you see these little objects on the wall, these are actually red lights. And so at nighttime, we turn off the white lights and then we turn on the red lights so that we can operate with the red lights and not ruin our night vision that much. So we look out, we go up to the roof and we look out towards the east. This is a 16 by 16 foot pier where we can set up 4 of those telescopes. And this is a post that includes power and data that we can plug into. And then this sidewalk going toward the parking lot looking west is wide enough where we can line up the Meade 10-inch telescopes, and we can have them looking at different things in the sky. The caveat is that we'll have the building block part of the sky, but if we move the telescopes out far enough, we should be able to see most of the sky. So we have a wide variety of telescopes from the Takahashi refractor. We also have a Newtonian, a classic 6-inch Newtonian back in the department, and we have lots of Cassegrain type telescopes. We also have several 20 by 80 binoculars, and we can mount them on tripods. And we do have a set of Oberwerk 4-inch aperture binoculars, the giant ones, that we can put on a parallelogram mount, and we can use that for public viewing as well. So I've had several nights of experience on the observatory since last July. So I'm getting to learn a little bit more about astro imaging. Now, back the last time I really had done at nighttime astro imaging, excuse me, was when I was observing Comet Hale-Bopp for my master's thesis. I was taking images, narrowband images of that comet back in 1996, 1997, and then the solar observations from 99 to 2001. So I have had some experience at Astro Imaging. And then these are images of the moon that I took through the Takahashi refractor with my smartphone. Line it up just right, and you can get a nice, nicely framed image of the moon, a little bit more overexposure to bring out the Earth-lit side, the Earth shine. And so these both were taken through a low-power eyepiece so that we can frame the entire moon. And so as I get ready to open up for a night of observing, so everything is looking nice. We have the clamshell gives us opens all the way up, or we can open part way up if we want to look at one side or the other of the sky. This is actually quite useful during the daytime because especially during this time of the year, when we open up the dome, we might want to open only a slit so that the telescope can look through that slit as the sun goes across the sky. Little piece of trivia, we had to suspend observations one day in 2000 at the Prairie View Solar Observatory because it got too hot. Back in the day, we were observing, we actually had the computer at the dome level and observing at the dome level, so we experienced whatever weather was going on out there, whether it's cold or heat. We did have a fan to keep us cool, but by the time it got up to 109 degrees Fahrenheit, and that's the actual air temperature, that got a bit too much, and so we had to shut down early that day. But we won't have that issue with this new observatory. So we have the Astro Haven opened all the way up, getting ready for a night of observing. Looking to the west, we see the Ash Dome, a nice twilight sky, but oh no, what's all this? Lights from the fabrication center, and that's one of the issues that we're having to deal with, is to get them to be shielded more adequately. So that's been kind of an ongoing thing we're going back and forth with that, and that's still one of the many works in progress with the observatory. If you look carefully, you might see a little bit of orange light reflected off of the trees here and here, and that's from the parking lot lights. West of the observatory, there's a parking lot that has two street lights that have LEDs that are the same color as the heat lamps that you see in the buffet places, and that's also the case for the parking lot across the street. So the developer and the builder did take into account light pollution. As a matter of fact, our architect has experience at Astro Imaging and observatories, and so he took all that into account. But again, we still have the issue of the lights in the parking lot, a few parking lots over, so that's something that still needs to be dealt with. But other than that, the skies that this observatory operates under is considerably lighter than the dark site. It's a Bortle class 6 sky, so we can barely see the Milky Way on a transparent night overhead. We're probably working with limiting magnitude about 5 or 5.5. Nonetheless, we think we can get past that by focusing on narrowband imaging of different objects. So these are some of the early examples. I know this is not quite as good as some of the astro imagers in the audience, but like I said, this is my early experience at nighttime deep sky imaging. All of these exposures are unfiltered, and they range in exposure time from 30 seconds to 120 seconds. And we have nice images of the Eagle Nebula, the Lagoon Nebula. We have these blooming stars here. But other than that, the nebula itself shows up nicely. The Cirrus Nebula right here. And then we have several clusters, the Wild Duck Cluster and the M3. And then the Deerlick group of galaxies, this is NGC 7331, and you can see its companion galaxies nearby. Now, one of the things, and then to the left is the Cocoon Nebula. Now, these images are kind of cool to me because they remind me, those of us that do visual observing and have done so over the years are familiar with how deep sky objects appear visually. They look more like what we see in these images. More or less gray, kind of fuzzy and so forth. But it's like with these images, we're taking it a step further with regards to sensitivity. So these are better than what the eye would be able to see in many cases with the same setup. But it's like we're taking it a little bit further, that we're saying that if we're able to see these from outer space, or if we had more sensitive retinas, these are what the images would look like. I can also use these in the classes to not only illustrate the different types of celestial objects that are out there, and the fact that emission nebulae, which this is an example of, is associated with an open cluster, since the stars form from the raw material provided by the nebula. I can also show them color images that are made, and we can compare the two, and I can share with them why the naked eye, the eye looking through the telescope visually, does not see all of the color and detail that we can capture through imaging. So a couple of more examples. This is the galaxy M101 in Ursa Major, the Dumbbell Nebula, M15, and then finally the planet Venus. This was actually taken during the daytime, during the late afternoon. What I did for the planetary image and also the lunar images that I'll show in a few minutes, I had left the ERF filter, the energy rejection filter, in place, and also the neutral density filter in place. I just removed the H alpha filter, so that way otherwise the light would be overexposed even at the shortest setting, and I wouldn't be able to get a good image. So it still looks a little fuzzy, but this is a more of a wider field image telescope. So the planetary disks do look rather small. As a matter of fact, you'll get an idea when we get to the lunar pictures what the width of the field is. It's 9 arc minute by 14 arc minutes. And these are some of my favorite objects to look at visually as well as imaging. The Swan Nebula on the left, and the Trifid Nebula on the right. So again, these remind me of the view that I get with the eye. You know, if we have an image enhancer eyepiece, we might be able to get these details or even some color. But these remind me of the images that I can see with the eye, colorless but yet detailed on the best of nights. I did manage to capture a couple of comets, and there's just a couple of, this is another thing that I'm trying to figure out, is why the, if I put in the coordinates, why it's several arc minutes off versus if I put in the name of the object, it actually goes right to the object, but that's another thing on my list. But this is an image of pan-stars. North is to the right, and east is up in this image, if I have this orientation correct. But the images are kind of on the side. The images are 14 arc minutes tall by 9 arc minutes wide, and this shows pan-stars with a short tail coming out. This is a 30-second exposure, and then this is the Atlas comet before it disintegrated, C2019Y4. This was a 60-second exposure, and we could see a little bit of a tail sprouting from this object. So we basically resumed our solar observation program in January of this year. So in summary, I was observing the night sky, the deep sky objects off and on from July until December of last year, and I continued to do so this year. We resumed regular observations of the sun this year once I found a nice adapter that can go into the H alpha filter and go into the telescope. I was able to get that setup completed. And again, the setup consists of the 16-inch Meade, the S-Big camera, and the 0.3 angstrom H alpha solar filter from Daystar. Unlike the last time I was involved in regular solar observations, this time the sun is more or less comatose. It's been very quiet for the last couple of years. We're in solar minimum, which was forecast to have its peak or depth in April. And so when the sun is at minimum activity, I'm able to use the center of the sun's disk as a good flat field screen. So what I would do is, to get 5 flat field images, I would dither the frame a little bit, and then those get combined in maximum DL. Each exposure is typically 0.09 seconds. The field of view, again, as I've mentioned, 9 arc minutes by 14 arc minutes. Flat field images were taken, as well as bias images at the end of a series. Normally what I would do in an observing program is to follow an active region that has a high probability of flaring, or we can observe several active regions throughout the day and follow their evolution. However, there's been no active regions to follow, so what I do is I go in the morning and I take the calibration images, the flat images, and then take a mosaic starting from one end of the sun, going to the other end of the sun, and each mosaic piece, I take 3 images, and so later these can be combined to produce a high resolution mosaic of the sun. I do that once in the morning and another in the afternoon, and then at the end of each session, close the dome, park the telescope, take biases, and then those get used in the later image processing. These are some examples. This is a small active region that popped up last January. You can see the 2 small spots here and the faculae right here. This is an off-band image of that region. And then this is what the region looks like on band with the plage, and we can see one of the spots here. So these are some examples of some images, but more often the sun looked like this. This is near the edge of the sun, looking at the edge. North is up and west is right in both of these images. And then this is looking at the center of the sun. We can see the texture, the H-alpha texture that's typical of this view, but this is typically what the sun had looked like for much of the year. Again, I observed on every clear weekday from Monday through Friday, usually in the morning and then in the afternoon, and then we shut down on the 24th when we had an issue with the clamshell that got stuck and didn't close, so we had to work with it to get it to close. So that kind of jarred us a little bit, and we stopped observations. And not only that, we had the stay-at-home orders and the effects of the pandemic, and so everything was put on hold. Now that we're getting back to work, we're starting to slowly get things back moving in the right direction, and I hope to be observing. We actually think we have a solution with the dome, and we plan to be observing again next week. Another big difference this time around versus when I was working with the original Prairie View Solar Observatory back in 1999, 2000, 2001, my only responsibility really was to operate the telescope and do the research that goes along with it. Nowadays, I operate the observatory, I teach a class, I help with the administrative duties, I manage the physics labs and so forth. So time for observing is a little bit more challenging to come by, but nonetheless, I'm able to carve out at least some time in order to get out and observe. We do have the capability, I'll just talk about this real quick and then I'll talk about where we're headed from here. Several different images of the waxing gibbous moon, and this again gives you an idea of the field of view that we have with our current setup. And so I have this oriented so that north is up and then east or west is to the right. And so this is a setup that's made again with the energy rejection filter and the neutral density filters in place to reduce the intensity. Otherwise, the camera would be saturated with the moon's light. This was actually made during the late afternoon, and that's why the background sky is dark, because of the filters that are in place. So we do have equipment to take color images and narrowband images of objects. We have a filter wheel that we're going to put together. We have a newer STT 8300 camera that we're going to use. So we'll get all that put together. We're going to check, we will verify the compatibility between that and the Meade, and then get the Sky X familiar with the new setup. Then we can start imaging. We will be partnering with we've been working with Doug Holland for many years. He used to work at NASA. Now he works, he has his own company. He's also a member of the HAS. You might see his emails periodically, but we'll be working with him over the summer to help bring the observatory up to speed. As a matter of fact, he'll probably be doing much of the imaging, as you imagers know, to do a proper narrowband imaging of a deep sky object that takes literally hours and hours of exposure time, which I don't have so much right now, but Mr. Holland's probably going to do some of that, and I do plan to get into that some a little bit later as well. So once we get these issues that we have with balancing and coordinating the dome and so forth, we do plan to do, we have a number of projects in mind for each of the telescopes. One of the visions that I have with the 16-inch Meade is to have a video camera hooked up to that to monitor Jupiter for Jupiter meteors. We've observed, actually not we, but people have observed more than a half a dozen meteors in Jupiter's atmosphere since 2009, 2010. And so one of the many things that I want to do on my wish list for this new observatory is to have a program to monitor Jupiter regularly, not only to follow the changes in its atmosphere to monitor its weather, but also to watch for meteors burning up in its atmosphere. And the other thing that we want to do is we want to build up a catalog of narrowband images of nebulae that we can fit within the fields of views of each of these telescopes. So we want to do that. We can do that pretty well with our light polluted skies. We can do some imaging, lunar and planetary imaging. And so there's a number of projects that we have in mind that we can do with these telescopes, not only us, but we're going to involve our students. We want to reach out to the area astronomy clubs, probably starting with HAS, and maybe work with people that would want to work, have observing time on these telescopes. Now the setup is that we can only allow maybe 1 or 2 people in the dome at a time. We don't have the setup up the code to allow large numbers of people, but if maybe 1 or 2 of you at a time want to come out and see the observatory in person, you can contact me, and we have been taking informal visitors off and on for the last year or so. So people, 1 or a small group of 5 can come out and we can show them around. Excuse me. So we also have plans to create new classes that are centered around what we can do with the observatory. Science majors will be able to take observations for their senior projects. We do plan to, at some point, introduce an astronomy component, an astronomy concentration, and have that be a major in addition to the existing physics major that we offer in our chemistry and physics department on campus. And then we do plan to have public observing nights and so forth. So we do have a number of activities and projects and such planned for the observatory, and that would be worth a talk in and of its own. But given the time, I'm going to go ahead and wrap things up, and I will take any questions that anybody might have.
Wonderful. Thanks, Brian. That's a really exciting presentation. Glad to see all of the continued development and improvement that's going on there at the university. We did have a few questions that came in through the chat. The question I had was about the Bortle class, and you answered that. You said about a Bortle class 6 sky out there?
Yeah.
Okay. Justin McCollum asked, what's the location for this observatory, specifically on the campus itself?
It's specifically on the east side of campus. And we're kind of sandwiched in between. The campus is growing, which is a good thing. However, in some cases it's not, because that means more light sources. A dorm, additional dorms and apartments are going up south of the observatory, and they've expanded a road that goes just south of the observatory going towards the east. And of course, that fabrication center, we looked at the lights from that fabrication center that's lighting things up quite nicely. So we do have the challenges of development. But the people that have worked with developing and designing and building this project have also talked with the contractors of these other projects, and they're going to get them to use responsible lighting practices and such, so as to minimize the impact on the observatory.
Wonderful. Okay. Chris Morissette asked, and I had the same question, do you have the contact information for the person that built the telescope mounts with the wheels? It's funny, I was looking for something like that just the other day.
Oh, yeah. As a matter of fact, I got to go dig through my email. What I can do is, I don't know if that's something that might be interested in, it might be something that is of general interest. I can put that on the HAS list and people might have it, or if you want me to send it to you, and you can send it to whoever is interested.
Yeah, however you'd like to do it, just let me know.
Okay.
Perfect.
Okay.
Justin again asked, he said, you can ask Brian about potential areas of solar physics research and the plans for the mission of the observatory in the first 5 years post the official opening of the observatory. What areas of solar research can be done at the observatory, or potential areas of research in the coming years post opening?
Well, right now, as a matter of fact, we've submitted some proposals, and we just got one of the notice for intent was accepted, and they've encouraged us to submit a proposal. And that reminds me, I think one of them is due next week. So thanks for reminding me. Actually, Dr. Cudnik is the one that's primarily working on it, but I need to kind of keep an eye out for, because he relies on us to help provide some support. But yeah, we're working on different projects. We're looking at, we were submitting proposals to help out with the Solar Parker mission.
Oh, really?
Take ground-based observations of the sun through various filters during the times when the probe passes perihelion. And I think we just passed one of them, and it happens like every 3 or 4 months, if I remember correctly. We did that proposal in December. Unfortunately, they didn't accept the initial proposal because we couldn't have somebody there 24/7. So they wanted 24/7, or actually at least 7 days a week, we can't go 24 hours a day in observing the sun.
Right.
But, you know, I mean, they wanted somebody there 7 days a week,
Right.
or have staff 7 days a week, and currently we're 5 days a week. One of the drawbacks that we have right now is that I'm pretty much, me and maybe one or two other people are pretty much the only ones that are really working on this, and I have other responsibilities as well. What we really need is one or two full-time dedicated astronomers to focus on this project in order to be able to be viable for doing research quality work, which is something we're slowly creeping towards. Right now, we could probably do some basic, like what we did in the early days of the Solar Observatory. We have H alpha capability. We can follow active regions closely and monitor their evolution and also their flare production throughout the day. We also can monitor filaments and their changes throughout the day as well. We do have a calcium K filter in our inventory that we can attached to our 14-inch mead, and we can take concurrent calcium K images of the sun. And then we want to get sodium D and helium D as well. So right now we're still putting the pieces together, but we are starting the observations to, once we get a little bit more activity on the sun, the main focus for solar physics observation will be the evolution of active regions. And we hope to very soon do that in more than just one wavelength.
Excellent. Okay. Bill Spazzeri asks, where can we get Brian's books? I did see one of them on Amazon. So
yeah, Amazon or Springer are the places I know of. And I know some stores have carried them. I don't know if they still do, but, you know, like Barnes and Noble would be one possibility if they're still existing. I know a number of these places are going out of business.
Yeah, unfortunately, but yeah, I did see them on Amazon as well, and I think you mentioned Springer when I was looking up your new book. Saw that there. So that one again, $800 plus. So yeah, but the other ones are much more affordable, and like I said, I read the first one and it was really good. What I'll do now is open it up for anybody else who has any questions they want to ask Brian. So you can go ahead and unmute yourself and ask the questions that you have.
I'll just mention real quick that I do have a couple of web links here that if you want to keep up with the project and the latest developments. One of them has been updated hasn't been updated since January of this year. So I hope to fix that. Maybe not next week. So I'm doing a week-long, I got some online training to be certified in teaching online courses. I need to do that next week, and I'm not sure how the time's going to be, but I hope to get that updated soon. But these are some links that you can look at our latest solar images and also keep updated as to what we're up to.
Excellent. We'll go ahead and add those to the HAS website as well, if you don't mind.
Okay, no, not a problem.
All right. All right, so going ahead and opening it up for additional questions. So if you've got them, go ahead and ask them. Not hearing any. So got to them in the chat. I guess everybody had them in the chat itself. So Brian, that's a great talk. Really appreciate your time tonight and sharing everything that's going on there at Prairie View A&M University. You know, it's just up the road from us on 290.
Yeah.
And it's exciting to see that, you know, astronomy is still alive and well, at least the visual astronomy at the universities nearby. And, you know, it's something that we see with, you know, U of H and Rice as well, where the observatories don't get used very often. So I'm excited to see that there are huge plans for those observatories there at Prairie View A&M. So appreciate it. Thank you very much.
Sure thing. You're welcome.
All right. Well, let me go ahead and share one screen here if you don't mind.
Go for it.
Bear with me one sec. Okay, can everybody see my screen, the thank you screen by chance?
Monthly general meeting, July 10th.
Okay, yep, there we go. So just wanted to make that last comment. So a few months ago, we voted to move the July meeting from July 3rd because of the July 4th holiday to July 10th. So mark that on your calendars if you plan on joining us. We're going to go ahead and send plenty of updates to let you know. But the meeting for July is going to be on the second Friday of the month, Friday, July 10th. And again, if you want to see more of this type of information, if you're a member, go to astronomyhouston.org. After we're done here, Brian's presentation will be uploaded to the website there, so you can view it there as well. And you know, lots of other meetings and recordings are up there as well. And if you do the social media thing, we've got links to our Facebook, Twitter, Instagram pages as well. And if you have any questions about anything that you saw tonight or anything generally about the club, you can always email us at info@astronomyhouston.org. So that concludes the meeting of the Houston Astronomical Society's general meeting, and we are adjourned. So thank you very much for joining us, everyone. We'll see you soon.
All right, thank you.
Take care.
You too.